from saying that the Big Bang Theory is probably doomed in light of what the James Webb Space Telescope has discovered in terms of fully formed galaxies at the edge of the universe, to steadfastly sticking with his and Sir Fred Hoyle's theory of Panspermia, Dr. Nalin Chandra Wickramasinghe, the Sri Lankan-British astronomer, astrobiologist, and mathematician, remains one of the most brilliant outliers in science. The 84-year-old Wickramasinghe is a pioneer of the science of astrobiology who, in 1974, first proposed the theory that dust in interstellar space and in comets was largely organic. It's a theory that has now been vindicated. He's a prolific writer both of technical scientific papers as well as popular expositions of his ideas. His total count of technical papers exceeds 400, some 75 of which have appeared in the most prestigious science journal, Nature. Dr. Wickramasinghe spoke to Mayank Shah reports from Cardiff in the UK about panspermia, the origin of life on Earth, and the steady state theory about the origin of the universe. Dr. Nalin Chandra Wickramasinghe. Uh, Co-mother, Professor, and Ayubowan to you.
Ayubowan, I mean, you haven't forgotten your Sri Lankan experience, right?
Yeah, I was married to a Sri Lankan lady, and I
Is that
used to
right?
report from Sri Lanka for quite some time. So
Okay, okay, okay. I
I
see. I
have
mean,
some understanding of the language, not much though.
right. I mean, I don't. I was born in 1939 during the last stages of the British Empire, right? So
Right.
my father was an ex-Indian civil servant. He was himself a mathematician. He went to Cambridge and so on. And we had a sort of anglicized background of growing up in the last days of the British Empire. So that's my background, and
Yeah, I'm
there
very
was also
familiar with. I read your autobiography. It was wonderful.
yeah, that was one version of it because I think I published that in Sri Lanka, and then there was a more expensive version published by World Scientific uh, Publishing House in Singapore, and that was a little better than that in terms of the detail, but the same story.
Right.
So my story begins in Sri Lanka, and I grew up in Sri Lanka. I went to school in Sri Lanka. I went to university in Sri Lanka, and as I told you, my father was himself a sort of great scholar in his own right. He was a mathematician. He went to Cambridge in the 1930s and got the highest honors in the mathematical tripos, beating all the English guys who were sitting for this. And then he had no job, and he was advised by his university tutors to try to enter the Indian civil service, which India was the crown, the
it
jewel
was.
in the crown of Queen Victoria. So that was what he started off with, and he went to India, but he didn't like it there because in the 1930s the situation in India was, as you probably know, was
Yeah.
very volatile. There was all these sort of struggles for independence and so on. So it wasn't a very happy place to administer on behalf of the British. So I think he left
Indeed. Indeed.
in despair, more or less. And
Yeah.
then he came to Sri Lanka and raised a family there. I have three brothers, and they are all scientists. It was more or less sort of a family expectation that we'd all,
I see.
in some way, be following the father's footsteps. So
Right.
that's what happened. I led the show. I sort of got really um, high praise and awards at school and university and so on. And my brothers followed. My brother, just 2 years younger than me, essentially because took to medicine, and he became a professor at Imperial College London, which in those days was a very difficult, very prestigious position. And the next one down the line was a mathematician. He took after, essentially, after he was inspired, I suppose, by me and took after me. And he also took to astronomy. So he became an astronomer. And eventually he became professor of mathematics and astronomy at the Australian National University.
I see.
And my very youngest brother is Kumar, 10 years younger than me. And he wasn't very good in school. He didn't excel in studies, but he ended up as a fellow of the Royal Society, a member of the National Academy of Sciences. He's an engineer. He's
Okay.
a nanoscientist, and that's my family. So I thought I'd just fill you in on the background of.
Yeah, it's all high achievers.
They were all high achievers, and as I told you, it was sort of more or less a family expectation that in the twilight of the empire, this man who excelled, my father who excelled in science and mathematics, would raise a family that would also uh, aspire to do science and things like that. So that's the background.
Right, right. I must point this out. I've been wanting to tell you this. In terms of scholarship, erudition, and a lucid writing style, you remind me so much of your fellow Sri Lankan, the late Dr. Anand Kumaraswamy. Uh, I don't know
Yeah.
if you've read him.
No, I've read parts of what some of what he's written. I mean,
Yeah,
he was a great scholar, and he was, as you said, he was a very skilled writer, and he
right.
had a very good style of writing. So I'm flattered if you say that my writing style is similar
No, it is.
to.
It is. It is. Okay, so let me get into the questions. I want to
Okay,
begin at the galactic center, particularly
okay.
the hypothesis that Sir Fred Hoyle and you had about the abiogenesis having occurred close to the galactic center and then having spread throughout the Milky Way via panspermia. That's quite an extraordinary intellectual leap. How did that come about?
Well, I think when I started work in Cambridge, I started on a project that was more or less sort of routine in astronomy, which was to try to understand the composition, the nature of cosmic dust. Right, cosmic dust shows up
Right,
as sort of dark clouds and striations in the Milky Way. If you look at the night sky on a sort of clear night, you see the sort of band of stars, the Milky Way stretching from horizon to horizon. And in between the stars, there are huge markings, huge structures. Some look like elephants' trunks, some look like coal sacks, and so on. So these were known from the beginning of the last century, but the nature of the particles of the stuff within those clouds remained a puzzle up to the time that I started working in Cambridge. I came to Cambridge in 1960 as a Commonwealth scholar to Trinity College, Cambridge, and I started my work in astronomy under the guidance of Fred Hoyle. So what I started to do was to try to unravel the nature of these huge dust clouds in space. We knew already that this cosmic dust made up pretty close to 1% of the mass of the weight of the entire galaxy. So it's not a trivial amount of material.
no, yeah,
And at the time that I started my work, my research, the consensus was that these were sort of ice particles, tiny microscopic ice particles, like the ice particles that you see in the cumulus clouds
right,
of the Earth's upper atmosphere, right? Now, I
right,
wasn't entirely, when I looked at all the data and tried to analyze the data, I wasn't entirely happy with that explanation, and I was looking for other explanations, other possibilities. And the one that seemed to fit much better was dust in the form of carbon particles, particles that were made up, tiny microscopic particles, sizes of bacteria, made up mostly of the chemical element carbon,
right,
right? And carbon, of course, is important because carbon is the main is what we are made of, basically, right?
right,
Carbonaceous molecules make up life. And so that was the starting point of life being a truly cosmic phenomenon. It didn't start like that at the beginning. We just thought of carbon dust, like soot
right.
particles to begin with. And as the 1960s proceeded into the 1970s, astronomy was developing at a fairly hectic pace, and there were new techniques and new technologies that were being used, and all of the new techniques that were used to study the dust showed that the dust was made of carbon. That was true, and that sort of was a verification of my original uh, ideas. But more than that, in the 1970s, the mid 1970s, the astronomy was showing that these are essentially very, very complex organic molecules, right? In the form of particles that were basically the sizes of bacteria, right?
Right.
So that was the start. And so we had Fred Hoyle and I were sort of puzzling as to how there could be so much. As I said, this is about 1% of the whole, 1% of the mass of the whole galaxy. How could these particles that were carbonaceous, organic, exist in such vast quantities? Now, when you look at the Earth's surface, you see organic molecules. They're everywhere, right? On the soil,
Right.
in the air, and so on. And the organic molecules on the Earth are all derived from biology, isn't it? Are
Right.
essentially
Right.
all residues in some form of living material. So by the end of the 1970s, astronomical research was progressing, and more data was coming in, and so on. And we had then to speculate, and I stress it was at this stage to speculate, that perhaps what we are seeing in the cosmos is very similar to what we have on the Earth. These are organic molecules, really complex organic molecules, some resembling chlorophyll, the green coloring substance of plants was also uh, implicated in the cosmos, right? And these were derived from biology, just as the stuff on the Earth is derived from biology. So that was the guess, the speculation. And then I think what happened next was really quite interesting, because family connection comes in. Uh, by that time, I was a professor at Cardiff University in the 1970s, and Fred Hoyle was an honorary professor at the same university. And on one occasion, my brother Dial, the astronomer, Fred Hoyle and I were having dinner at our house, right? A curry that my wife had made. And we were talking about all this stuff in space and so on. And then Dahl asked the question, is there anything I can do at the telescope that would resolve this issue, right? Because he had access to what was then the world's biggest, most powerful telescope, the Anglo-Australian telescope. So we told Dahl, look at the most distant star near the center of the galaxy, preferably, because that gives us the longest sort of path length through interstellar cosmic space. Find a star there and get what we call a spectrum in the infrared, right? A sort of characteristic absorption signature, and see whether there is a signature of a bacterium or living material, right? Not just chlorophyll or amino acids, something, but the whole assembly of a bacterium, right? And so he said, yes, I'll go back and do it. And with great difficulty, he got permission to do this, because all his colleagues said, this is crazy. There can't be any life out there. So why do you want to do this? But he was influential enough at the time to get this done. And he had, within 2 or 3 months, he produced this spectrum, what's called a spectrum, infrared spectrum, of cosmic dust along the whole of the galaxy up to the center of the galaxy, right?
I see.
And at the same time, I had a PhD student in Cardiff, who was looking at properties, behavior of bacteria if they were in space, right?
Okay.
bacteria
Yeah.
could be tested in this way, right? Could be looked for in the way of by using spectroscopy, as they call it, right? So
Right.
this guy, an Iraqi student, had obtained already a spectrum, infrared spectrum of a freeze-dried bacterium, as it would be in space. And space is
I
there's a
see.
vacuum in space, so all the water will evaporate, it will be freeze-dried. And so we had this spectrum. And as soon as Dahl sent his astronomical spectrum, we compared it with the laboratory spectrum, and it was spot on, point by point. The
I see.
yeah, over a huge wavelength range, right? And now in science, if you have make a prediction that is as accurate as that, and you have a result that fits that prediction, then this is essentially proof of your hypothesis, right? Or goes a long way towards saying that this is it. The
Right.
stuff between us and the center of the galaxy is biological, right? So this was a really exciting moment through the 1980, 81, 83. We had meetings, conferences, and so on, essentially uh, uh, announcing this result and
Mhm.
challenging our opponents to say why it is not so, why it could not be so.
Right.
And of course, there were many, many dissenters because people didn't like to say there's so much life out in space and so on. But over a period of about 3, 4, 5 years, the astronomical data became crushing to a point that we thought we have to just go head on and go with this assumption, with this hypothesis, be brave. And against all the opposition, we pushed this. We looked for data, looked for confirmation, and so on. And every prediction was fulfilled. And so that was it. So uh, by the mid 1980s, I think, or mid to late 1980s, there was no doubt in our mind that this is a theory that had to be launched in a very big way. The
Right.
theory of, or the new theory of panspermia, right?
Right.
It's an ancient idea, of course, goes back to Greek times, to Vedic times in India as well.
Indeed. Indeed. Yeah.
Mm. So that was it, and to this day, the idea is getting more and more support. Every time you make a prediction, the prediction is appears to be fulfilled.
Right. Why do you reject the idea of earthbound abiogenesis
Well, it is
separately from the galactic center?
yeah. Well, the standard theory of life that has been essentially a Eurocentric theory of life is that life started on the Earth through random processes with complex, some reasonably complex molecules getting together and forming the first living system. Now,
Right.
if you examine this in the 1960s, this was thought to have happened uh, 3.5 billion years ago, right? This was the moment in time that was being talked about in the 1960s. By the 1980s, we were getting to 4 billion years ago. It was getting further and further back, right? The first event of abiogenesis, if that ever
Right.
occurred. And then, the most recently, about 2 years ago, we have found evidence of microscopic life in the oldest rocks that were formed, which was about 4.3 billion years, right? And now 4.3 billion years ago is a moment in time when the Earth was simply pounded with
Right.
comet impacts, right? There
Right.
was no chance that any quiescent process could have been happening on the Earth. But if there was life everywhere, if there was life in comets, and I'll come to that in a minute, right?
Right.
These comets could have dumped the first life that is now visible, examined in the laboratory inside of rocks. But I mean, I think the main objection we had when we really were thinking through these ideas in the 80s and 1990s was a matter, was an issue connected with probabilities. If you take the standard story, the abiogenesis story, seriously, then if one is given, provided with all the amino acids that make up proteins, with all the nucleotides, components of nucleic acids that make DNA and RNA, and put them into a huge ocean, what is the probability that these would assemble into a simple self-replicating living system? And we can take one example. How could the proteins in a bacterium
Right.
assemble from the 20 odd amino acids, right? And this is a calculation that is, as mathematicians, we were very adept at doing. And when we try to figure out the probabilities of that happening, it turned out to be like 1 in 10 raised to the 30 or 40,000, right? So you can forget about it. It's a miracle beyond any conception that is required to transform the chemical building blocks of life, right,
Hmm.
like the nucleotides and the amino acids, into a working, a fully working, simple living system. So that was the problem that we faced. If there was a problem there on the Earth, then where could it happen? And then I think one is forced to go to bigger and bigger laboratories, bigger and bigger systems. And so eventually, I think we came to the conclusion that the whole universe has
Right.
to be implicated in the origin of life. So life and the universe, then, according to our current thinking, they are inextricably interwoven. There's no easy way to say one came before the other. And I think
That's
that's
right.
where I stand at the moment. I don't think that it's an explanation, a full, uh, gives you a full understanding of how
Right.
life began in the universe, but I think it certainly tells me absolutely convincingly, in terms of all the data, that life could not have started on a small scale on the Earth, or indeed on any other planetary
Right.
body we can think of.
I see.
So that's that's
Yeah,
that, that's
absolutely. No, it's fascinating. The way you're describing life, the universe teeming with life, it
mm,
essentially appends all Eurocentric dogmas, either in religion or in science, about what we have come to believe for centuries. And do you think that could be one of the reasons why there has been so much resistance? After all, as you pointed out, the term panspermia was coined by the Greek philosopher Anaxagoras 500 to 428 BC, which is about 2,500 years ago.
yeah, yeah, yeah. Certainly, I mean, I think the fact that this is the orthodox position is the spontaneous generation of life. That's no question about the orthodox European or Eurocentric
Right,
position is that. But the much earlier history is very interesting because, as you said, Anaxagoras, uh, before 500 years before the Common Era, he suggested this, and he was a very influential astronomer. He had many supporters and followers. But then, 200 years later, we have uh, the uh, the competing theory of Aristotle coming in, right?
right,
Aristotle was also a very prominent philosopher, and he opposed the ideas of Anaxagoras very extremely strongly. And that was the turning point in a European transformation of the understanding of origin of life from cosmic to terrestrial, because Aristotle thought that fireflies emerge from a mixture of warm earth and morning dew. This is one of
yeah,
his.
yeah,
Uh,
yes,
you've heard that, right? So
yeah,
there were many statements like that, and right through the Christian era and the dawn of Catholicism, and the Roman Catholic Church also had to play a big role because by the 12th century, Aristotle was part and parcel of Christian theology, right? Christian theologians took over the whole corpus of Aristotle's philosophy and tried to sort of mold it into their own story. And so this is what has kept the whole business of spontaneous
Right.
generation alive. And what really amazes me, Mike, is that now in the 20th century, in the last 50 years, the most powerful chemical laboratories in the world have been attempting to make primitive life from non-life, right?
Right.
With dismal failure. Not a single experiment
Right.
has succeeded. And so I think one has to just throw this out of the and
Right.
regard it
Right.
as being an imperial artifact. And of
Yeah.
course,
Yes.
the Western Empire has imposed that on us, imposed that on all our thinking.
In contrast, Eastern religions and philosophies, especially in India and elsewhere in Asia, they have been remarkably open to this idea of life having a universe teeming with life in many ways. Like,
Absolutely.
yeah. And why is it that? Why do you think people in that part of the world are more open to this idea?
Because they're not shackled by the constraints of Judeo-Christian theology. I think that, I mean, that's a hard thing to say in a Western context, but I think we have been molded in the West
Right.
by the thinking that has gone from the ideas of Judeo-Christian. Let there be, God said, "Let there be light," and there was light, and so on,
Yeah.
and the Garden of Eden, and all that sort of stuff is uh, is basically Earth-centered. The Earth is the center of the world. In the early
Yeah.
Christian dogma,
And
certainly it wasn't.
sorry to interrupt, but it's not just Earth centric, it is almost anthropocentric. The view.
Anthropocentric, yeah,
Yeah.
yeah. Humans are made in the image of God, right? So
Yes.
we have a direct link with God, and
Yeah.
so this is the problem. And whereas the Vedic traditions in ancient India were much more open. I mean, I think my personal view is that the, um, if life is a truly cosmic phenomenon, that knowledge must lie deep within each and every individual, and sort of the ideas of going to the Himalayas and shutting yourself out from all the trimmings of the world and tropics of the world, and meditating for days and days, and saying you probably tap into the real truth
Right.
that is underlies the nature of the universe. I think that's the way I would like to see the
Okay.
connection with
Right.
and
You were the first.
mm,
No, go ahead. Go ahead. Sorry to interrupt.
no,
Go ahead.
no, I mean, just to connect to extend what you said. I mean, Vedic traditions say that this is true. So also does later Buddhist traditions, right? So,
They do.
assert that life is a truly cosmic uh, phenomenon, isn't it?
Right. And you were the first to propose that interstellar dust is made of organic molecules. That's an
Absolutely.
that's an extraordinary idea. What is the origin of that thinking?
Well, because the ideas that were before the ideas that existed before and were fashionable before I came on the scene was that the cosmic dust was just bits of ice, microscopic flecks of ice, like the particles in the Earth's upper atmosphere, the particles that make up the white clouds in the sky, right? And mathematical calculations and astronomical observations showed within 5 years of my starting work on this, showed that this totally wrong. And I had maybe a 5 year long struggle to get scientists to accept that,
Hmm.
the bulk of the cosmic dust was not inorganic ice. I mean, that was a very difficult hurdle to overcome, but I did overcome it.
Hmm.
There weren't the religious trappings for that particular uh, transition from ice to carbonaceous material. And nor was there, I mean, I was also the first in 1974 to publish a paper in Nature saying that the cosmic dust was organic, comprised of organic polymers. right? Long strings of organic molecules. That was resisted by many people, including Carl Sagan, said, how can these complex molecules survive in space? Because space is a very harsh environment and so on. So we had a ferocious debate in the columns of Nature, but eventually this idea is also now generally accepted. No one
Right.
distends from the fact that organic molecules, molecules that resemble the molecules of life, are everywhere in the cosmos, and they're now called prebiotic molecules,
Right.
right? Because they don't want to say that life is out there. They think that these are just the components of life. They still want, the orthodoxy of science still want,
Yeah.
absolutely demand that these molecules have to be brought to the surface of a planet like the Earth and then assembled in the way that Aristotle told us,
Right. Right.
the third century BC. So I think
Yes.
it's absolutely horrendous, the um, the obstacles that we're facing. But I think they are being overcome. They are being
I see.
very slowly overcome because facts eventually have to win over ideologies, falsehoods, and so on.
Right.
So I think
Right.
in the fullness of time, myself and my colleagues and so on will be recognized. Fred Hoyle, particularly, will be recognized as being the transforming uh, guys who influenced it, made the most important transformation of thinking in
Right.
the 20th and 21st century.
Yeah. One of the main reasons why your thinking and hypothesizing have been described as fringe relates to the explanation about how bacteria and viruses get into comets. And you have a very elaborate response to that.
Yeah, well, I
Would
think
you?
I think the French means that only a few scientists accept it, which is true.
Yeah.
Which at the moment it's true. I mean, the few scientists that are accepting it, or a small fraction of scientists, of the total cohort of scientists who accept it, include some powerful scientists at the moment, right? There's no question about it. But it is still a minority position, and the majority position is the imperial position, imperially sanctioned position, sanctioned by the British Empire amongst other European empires, right? That life has to be a purely terrestrial affair. That we cannot involve the universe with life. We can involve the universe with everything else, but we cannot say that the universe is living in any
Right.
sense. And so that's become uh, largely a cultural issue, I think, that has to be
I see.
overcome. But
Uh,
eventually, it is going to be overcome because culture has to be has to play a secondary role to science and to facts, and the facts are very, very, to me, extremely clear.
right.
And there's an increasing body of evidence, rapidly increasing body of evidence that uh, essentially proves this point of view that life is truly cosmic. Well, I should tell you one particular story of interest. When we had found evidence, spectroscopic evidence of living material in space and so on, and the first comet that came in the space age, which was Halley's Comet in 1986, when it was studied by astronomers, including my brother, in fact, in Australia, and found to be have a dust tail that matched the behavior of bacteria. All that was sort of piling up to a point that we decided to ask the question: if comets are carrying this material, throwing this material out in vast quantity, uh, is there no experiment that we can do on the Earth to show that comets are actually, even today, bringing in living material, right?
Right.
We know, Mark, that something like 100 tons of cometary debris are dumped into the Earth's atmosphere every single day.
Yeah.
We don't know what it contains. Most of it gets burnt in the trip through the Earth's upper atmosphere, but some of it survives. And so, in going back to the 1960s, 70s, and 80s, we asked the question: is there no way in which we can probe the upper atmosphere or the stratosphere, right? Send probes
Right.
up through the atmosphere into the stratosphere, collect this material before the incoming cometary debris, before it gets mixed up with the Earth debris, and see whether there are bacteria coming in.
Right.
And again, this is cultural obstacles that we face. We approached the British aerospace, we approached NASA. No one said that. They said that we don't want to waste our time on this. We're not going to find anything interesting. So uh, I had my colleague Nalika in India, who was
Right.
head of the Indians, one of the Indian research organizations, and so he approached the Indian Space Research Organization, which was and still is a very powerful space organization. It's sent stuff to the moon. It's done.
Right.
It
Mars too.
launches.
Yeah.
Yeah, it's a very powerful organization. So director, the chairman of ISRO, uh, Dr. Kasturi Rangan, took on this
Right.
project with great enthusiasm. And in the year 2000, we sent a probe to the stratosphere, collected material, that brought it back to the Earth, and we found bacteria, right? We found bacteria, definitely, no question about it. And some bacteria that we found were so novel that we reckon that they certainly could not have lofted from the Earth and come down again.
I see.
It was indigenous to the material that was being brought, right? So that was the first ISRO space probe or atmospheric probe. Then we had these Indians did another two experiments and found new organisms, one of which they named after Fred Hoyle, one after an Indian astronomer called Aryabhatha, right?
Yeah.
And these are
Sure.
not,
Sure.
they were not known on the Earth. So that this was what's happening in the 2000 to 2010. And then about 5 years ago, I should tell you that the Russian astronauts were scrubbing the outside of the International Space Station, which is now going very, very high up. It's above the stratosphere. It's at 300 or 400 miles above
Right.
the Earth. And they found cultures of bacteria. So they swabbed the windows and found these bacteria. And the astronaut, if you look at the internet, the astronauts who studied it
Yeah.
are absolutely convinced that these came from outside, that they could not have been lofted from the Earth. But
Yeah.
there's deathly silence on this from the United States and so on, right? So it's a major crisis of perception, of admission of facts, and so on. And something very quickly, very soon, has to give. Otherwise, I think we are bogged down in hypocrisy. Science,
Right.
we can forget about science if we
Yeah.
are maintaining hypothesis against all odds.
Right. No, this is a perfect segue for me to come to something specific. COVID-19, having been part
Yeah,
of a meteor strike, carbonaceous meteor strike on October 11, 2019. In that context, you also believe that the 1918 Spanish flu uh, was something
yeah.
similar. I'm very
I think
fascinated by that. Explained. I mean, 50 million people died in 1918.
Yeah, I mean that the data on that. I mean, it might be surprising. This is a century old. Is a little more secure and free of political maneuvering and so on than the COVID data. COVID data is sort of essentially befuddled now with all sorts of political ramifications. So let's go back first to the Spanish flu, 1918 and 1919. The data that we analyzed in the 1970s of all the data that was published on this pandemic showed clearly that there was no transmission, no significant transmission from person to person. Right? We found remote areas of Alaska suddenly coming down with with large numbers of people going down with the flu and dying. And in those days, travel was very difficult. You could go only from the cities to the remote parts of Alaska on sledges. So there was no way in which person-to-person contact
Right.
was responsible. And there's also a very interesting bit of data that we've written about several times. The first attacks of a particularly lethal wave of this influenza occurred in Boston and Mumbai,
Right.
on exactly the same day,
Right.
right? Now, this was a time when there was no air travel in the 1920s. There were no airplanes ferrying people. So how did that happen? I think it is clear that all of the evidence that we've studied is clear evidence of a strike from space, and why not? I think if bacteria and viruses are cosmic artifacts, are cosmic uh, fragments of cosmic life, then this is not difficult to understand. So that's the position that relates to the 1918-1919 pandemic, and every single pandemic in history, like for instance, even going earlier to Greek times, the plague of Athens, for instance, is suddenly struck. An unknown plague, a hitherto unknown plague, suddenly struck Athens in the middle of the Peloponnesian Wars, and it's
Right.
been described in great detail by the historian Thucydides. And if you look at the descriptions of Thucydides, again, it is very similar to what we found later in pandemics, all the way to the COVID-19 pandemic. But as I said, the COVID-19 pandemic is fraught with all kinds of political
Yes.
ramifications, including the conflicts that are raging between the United States, the cultural conflicts that are raging between the U.S. and China. That doesn't help to get a clear picture of what's
Right.
going on there.
Right. In one of your papers, you quote from the Buddhist text Anuttara Nikaya from the first BCE. And I would like to quote that: as far as these suns and moons revolve, shedding their light in space so far extends the thousandfold world system. Now, essentially, what it says is that what you've been arguing all along. So,
Mm.
tell me a bit more about that particular text.
Well, I think that again ties up with the Vedic ideas of planets being everywhere in the universe, the Earth not being alone as a planetary body
Right,
that is harboring living creatures. Uh, well, I suppose this also ties up with the modern discoveries of about a decade ago, of less than a decade ago, of exoplanets. Right?
right,
We've been speculating about planets like the Earth, planetary systems like our solar system, existing outside of our own little region of space. Right? The
right,
sun is just one of 100 billion similar stars in the Milky Way. And what astronomers have found in the last decade, is that something like 1% of those stars in the Milky Way are very similar to the sun, and similar to the extent of harboring planetary systems. So exoplanets have been discovered in large numbers, exoplanetary systems, right? And the average distance between our solar system and a neighboring exoplanetary or solar-like solar
yeah,
type system is only a few light years. And my
right,
colleagues and I have worked out quite convincingly that to transfer material from our solar system, the bacteria from the Earth and the sun, comets around the sun, to the next neighboring planetary system, exoplanetary system, is trivial,
I
right?
see.
They're almost kissing each other. So if there is
Yes,
life in on one system, like on the Earth, in our solar system, there has got to be life across the entire galaxy. There's no question about it.
yeah,
And people are coming around to this point of view with great hesitation, with sort of ifs and buts and maybe not and so on and so forth. But it's all down to cultural
right, right.
obfuscation.
It's interesting you should mention that, because the way you're describing it in your mind, the question of life being everywhere was never a question, really. You always thought there ought to be life across the universe.
Well, I think, yeah. Even before I became a scientist, and before I started analyzing all these new data sets that emerged from the 1960s onwards, my instinct was that life is truly
Right.
cosmic, and that life is cannot be confined to this little planet
Right.
that we are sitting on,
Yeah.
or standing on.
Right.
And that is partly cultural. I think the fact that it comes from an Indo-Aryan, Indus
Right.
Valley type civilization
Yeah.
makes a difference. And I think that that has been also the situation in India, because my colleague Nalika has worked with me, and
Yeah.
recently we've published a paper, and we've had difficulty in publishing it. Now
I
we've got
see.
a publisher for it, where we analyzed, Nalika and I analyzed the latest data from the James Webb Telescope, right?
I was coming to that. Yes.
Now, the James Webb Telescope started operating only about 6 months ago, and it's already finding really staggering
Absolutely.
results that
Yeah.
blows apart the whole of conventional astronomy and conventional cosmology, and I think
Right.
conventional astrobiology as well. What they found recently is that there are galaxies that are 35 billion light years away, mature galaxies like our
Right.
own Milky Way system,
R-
as far away as that. Now, the standard story of a Big Bang is that everything started from nothing, ex
Yeah.
nihilo. God said, "Let there be, let there be a universe." There was a
And there
universe.
was. Yes.
So now that happened. The conventional wisdom was that happened 13.8
8 billion.
billion
Right.
years ago, 13.8 billion years ago, which is really, I mean, coming that even that time scale was sort of, I found it amusing to have such a short time scale. Fred Hoyle thought only three times the age of the Earth, the whole universe. There must be something wrong with that, right? So
Yeah.
anyway, that's what came from the so-called Big Bang theory. And now what they're finding is that these galaxies there are much older galaxies. So the whole of the Big Bang is in Big Bang theory is in great trouble now, and
Now, yes.
the only theories that survive are those that
Yes.
were essentially supported by Nalika in India, and
Yeah.
currently by Roger Penrose in Oxford. He's a Nobel
I,
laureate.
it's amazing, Dr. Wickramasinghe, the way you're answering. It's exactly following the questions that I have. The next one was about Professor Penrose's conformal cyclic cosmology. I'll come to that, but before that, do you think what the JWST has found, the James Webb Space Telescope has found, in a sense, revives the idea of the steady state that Fred Hoyle and two others were
Nalika,
so
Babbage,
completely convinced about. Yeah,
yeah, absolutely, absolutely. I mean, there's absolutely no doubt in my mind, and there never was any doubt that the universe is much older, has an infinite age, and that's the wisdom of the ancient Indians, right? Vedic
right.
traditions say that the universe had no beginning, and it's a cyclic event, a
Indeed.
cyclic process. So, I mean, there's no question about it that this is going to be the ultimate truth that would emerge when the most powerful telescopes in the world, the James Webb and other telescopes that come after it, have done their work. I mean, the truth is always out there and cannot
Yes,
be subdued, isn't it? I mean, this is a fact of life. You can use cultural processes of culture and so on,
right.
imperial uh, conquests to force people to believe things, to believe in slavery, or to
Right.
believe in these other things. And but the truth is always the final arbiter of the universe.
Right. What do you think of Professor Penrose's conformal cyclic cosmology, which he himself has said is a bit more like Hindu philosophy? These are his exact words,
Yeah, yeah,
than the Judeo-Christian traditions.
yeah. Well, I think there's not a lot of difference mark between the Penrose position and the older position, which goes back about 2 decades or 3 decades earlier, of Hoyle, Nalika, and the Babbages. Right? Uh,
Right.
Fred Hoyle used the words Big Bang theory as a
Yes.
derogatory to essentially to say that this is nonsense. Big Bang is a Big Bang. And you can think of firecrackers going Big Bang, but
Right.
the universe going Big Bang is it's just crazy. So I think the Big Bang theory is doomed in the long term. As a scientist, I would probably be hanged for saying that, but I'm old enough to tackle that
you,
one. I think it's going.
it's one of the greatest ironies of science, physics especially, that the pioneer of the steady state also, in a sense, created the idea of the Big Bang pejoratively.
Absolutely. I thought he thought it was a joke.
Yes.
He thought he and Burbage and Tommy Gold, I think, was
Yeah.
other, Gold and Hoyle were the
Right.
first prime movers on that. Then Nalika came along, and Nalika and
Yeah.
Hoyle worked for several decades. And so it's Nalika is still in India, and he's an honorary professor at in Pune, and I've visited
Yeah.
him many times.
Right.
He's-
I take it you are a steady stater.
Absolutely. I have no
Okay.
doubt that the universe
Okay.
has existed for an eternity. I mean,
Okay.
that's what I have been brought up culturally, religiously, and as you
Right.
said, Buddhist philosophy, Hindu philosophy
Yeah.
uh,
Yeah.
doesn't make any. There's no other alternative, isn't it?
Yeah. Yeah. It to just to wrap up last couple of things. I've taken enough of your time. What role do you think gravity plays in the way life might have emerged elsewhere in the solar system, as well as even the universe? Because I would presume, say, for instance, an exoplanet where the gravity is twice Earth's or half Earth's, life forms would evolve very differently, don't you think?
Yeah, well, I think the component, what is cosmic and universal, are the components of life, right? The
Hmm.
genetic, all the genetic possibilities, whether a living creature can be big or small, or able to fly or walk or whatever, just depends on the locality in which the information units, like the viruses and bacteria, right, uh,
Right.
are, are put together, right? The totality of possibilities, of all possibilities for life, for intelligence, for everything that you can think of, exists out there in vast quantity in the form of bacteria and viruses. So when these rain, if this material rains on a planet that is lofty, huge, and so on, then the creatures that would evolve or would essentially survive are the smaller ones, isn't it? If you have
Hmm.
tall, huge creatures walking on a huge planet, then there's a problem. So the environment, the physical environment, selects from an infinity of possibilities those structures and those possibilities that are best suited to the local conditions. I think that's
Right.
the way I see it. I think the the totality of cosmic life is a huge, is an almost infinite resource for evolution. Evolution of life on any planet depends on the local conditions, local physical conditions that prevail.
Right. One of the questions that I have grappled with as a lifelong science nerd and physics nerd, as it were,
Yeah,
is whether there is any purpose to this monstrosity called the universe. I'm not looking at purpose from the human standpoint, but what is the universe doing being so huge and so diverse and so magical? What's going on?
yeah. Well, that's $1 million question, and
Yes.
I would ask. I keep on asking that myself. I think there's no rational answer, no reasonable answer that we can offer at the moment. I think that uh, if there is a God, a creator, or Vishnu, or whoever the great creators
Right.
are in the Hindu mythology, they essentially encapsulate the entire universe. The universe is creator and created all combined together.
I see.
I don't know that I don't think
Yeah.
that answers the question, but
No,
I think
it's interesting, but that brings me to wrap up our conversation. Where do you stand on simulation? That
on
we are we live in a simulation, or we are simulation.
I find myself being very cynical because I think the evidence from there is no question that the components of life are that are microbial components of life are being continually replenished from outside, right?
Right.
We depend all our functions in the human functions, like functions of the brain, functions of the gut, depend on what is called a microbiome, right?
Right.
And that
Right.
microbiome is derived from the stuff that is in the air, it's falling down from the sky, it's coming from the stratosphere, and so on. So we are continually being connected. We are continually connected with an external microbiota.
Right.
Uh, I think there's no question about it. Whether the external microbiota can manipulate our behavior is another matter. I think that is a possibility that I've been toying with. I mean, could a cloud of bacteria have an intelligence that is inherent in that cloud? And
Mhm.
uh, can that intelligence be transferred to the organisms that are
Right.
receiving that
Right.
microbiome?
Yeah.
Um, I mean, we have. I think it's interesting also to touch briefly on the search for extraterrestrial life. Right, we have
Right.
over nearly 50 years, or a little over 50 years, been searching for extraterrestrial life in the form of radio signals, and
Mhm.
so far, as I think, as consensus tells you, there hasn't been any convincing detection of an extraterrestrial signal. Radio signals are what people are looking for. What if the messages that are being sent are microbial messages, right? Like a
Absolutely.
cloud
Yeah.
of bacteria carrying information, like, I mean, in a silly sort of way, like Fred Hoyle's novel, The Black Cloud,
Yes.
right? I mean, this was
Yeah.
a cloud of bacteria, of organic material that had intelligence. So, is it possible that these things are coming in and they are essentially sort of pulling the strings for our behavior? Are we, in our behavior towards all sorts of things, including COVID
Right.
19, are we being manipulated?
So, in a
Uh,
sense, we are already connected to that
we are
extraterrestrial
connected.
force.
We are connected to a huge resource, a huge source of infinite source of intelligence. The bacteria are
Indeed.
not stupid, right? If you
Right.
get a clump of bacteria on a sheet of, I mean, sort of on a table or something, those bacteria very quickly drift to the place that it can get food, it can get
Yeah.
nourishment, and so on. Like just like ants,
Yeah.
bacteria have
Yeah.
the same kind of. So they have an intelligence, and the question is how advanced, how sophisticated can that intelligence become if we have trillions of bacteria, right,
Right.
all acting together? I think it's an open question. I think there is no doubt that this is a striking possibility that has to be explored.
Right.
Uh, and are we simulations in any other way? I don't know. I think simulation. We could be we could be subjects of manipulation through
Right.
bacterial ingress from space,
Right.
and the aliens that we are looking for may be all bacteria.
They're
They could be
already here by that argument. Yes.
already here.
Yes. To conclude, where I mean, this is not a subject that really fascinates me much because I am a complete unbeliever, non-believer, whatever you call it, atheist. Where do you stand on the question of God?
Where do I stand on the question of God? I think I have an open mind, in a very abstract way, an open mind. I do not believe in any sort of physical representation of God.
Right.
God, to me, is the total content of intelligence in the universe. The
Interesting.
universe itself collectively is incredibly, infinitely intelligent. And so that will be my God, the
Okay.
universe with all its bacteria, with all its viruses, with all its physical interactions, all the quantum interactions that are taking place. It's a huge resource of very complex information, and
Right.
that to me is intelligence at the level of God.
On that note, Dr. Wickramasinghe, I personally believe you should have been given the Nobel Prize for panspermia, the idea of interstellar. It's an extraordinary idea. I don't know why it hasn't happened. It should have
Well, I
happened.
think, yeah, well, I think, I mean, I don't want
No, I
to
understand. This is my view. That's all.
yeah, yeah. Well, I think it's an idea that is revolutionary, absolutely transformative in human history, and it is being resisted only for cultural reasons. That's the
Indeed,
problem.
it appends everything that we stand for as a human
It
race.
offends everything. It offends
Yeah.
academies. It offends the integrity. I mean, all of the academies of the world, like the French Academy, the Royal Society, and so on, they started in the 16th, 17th century to confront and to combat superstition and like witchcraft and so on. And
Right.
now they come to a stage when they are essentially themselves supporting uh, obsolete ideas and essentially perpetuating superstition in a very general way.
True.
They're
True.
resisting change, resisting paradigm shifts that are long overdue. I think the paradigm shift from Earth centered life to cosmic life is long overdue. It should have happened 20 years ago,
Right.
right? And when Fred Hoyle and I first came up with this idea, Fred was visiting me in Cardiff and he said, we should publish this paper in Nature immediately. But of course, Chandra, you realize that as soon as, and I was just 38 or 40 at the time, right? I was a
Hmm.
young scientist.
Right.
Of course, you realize that as soon as this is published, your application to the Royal Society will be tipped in the bin. I said, who cares? And I
Yeah.
decided to take that risk or take that possibility, and this is what happened. So I think the academies have a large responsibility. The academies that are supporting orthodoxy in science, they have to reform, and unless that happens, I think we are stuck in the mud.
On that note, Dr. Wickramasinghe, it was an absolute pleasure for me to talk to you.